30-pound pole is placed against a smooth wall at point B. It's smooth wall, that means that there is no friction, and a rough ground at point A, there, that means that we're going to have friction in here. Will the pole remain in this position or not? Again, we need to draw free body diagram and show all the forces that act on this pole, and then use the equation of equilibrium to find these forces, and then we need to compare the force that we find from here with the force that we calculate using the equation, the friction equation itself. Now, because there is no friction in here, we have just N, and we use NB over here. Then there is weight, which is 30 pounds acting there. Then at point A, because there is friction, we have this normal force, which is NA, and also we have F. I use FA to show it, and later, like I say, first I will calculate this FA using equations of equilibrium, then I will calculate the same F using friction, and I will compare them with each other to see whether they are equal or not, and it's enough to hold it in position or it will slip. Now, the distances here we have 5 because the total is 10. Also, I need this height. This height is equal to, so I use h, I calculated in here. It's going to be equal to 26 square minus 10 square, and if you solve this, it's going to be around 24 feet. Now I calculated it. I have all the components that I need. I can go ahead and write the equations of equilibrium again. So equations of equilibrium. Again, I will start with sigma m. You have noticed every time we solve this problem, we pretty much start from taking moment about a point that we eliminate some of the unknowns. By taking moment about point A, I eliminate N and F at point A. Now, if I assume, again, this is my positive direction, then I will have negative NB times the distance is 24, I just calculated, plus 30, because this is going to act in the positive direction that I assume, plus 30 times the distance is 5, and those are the only forces creating moment. Therefore, I can from here calculate NB, and NB is equal to 1500 divided to 24. That's 6.25 pound. I calculated NB. Then if I write sigma fx is 0, I can find, oh, I should write here is 0. I can find FA, NB, which is 6.25 minus FA is 0. Therefore, FA is equal to 6.25. So this means that I need this much force to hold this 6.25 pound force to hold the pole in position. We will see whether the friction is able to produce that much force or not. To calculate friction, I need N. Therefore, I write sigma Fy is 0 to find N, and from there, Na is equal to 30 clearly, because Na minus 30 is 0, therefore Na is 30 pounds. Now, I calculated all the unknowns. The important one is this Fa. I need to compare it with the F that friction is producing. At point A, friction is able to produce mu Sn. This is the maximum force that Fa is able, friction is able to produce at point A. Now, mu s is 0.3 times n at point A we calculated is 30, and that's equal to 9 pounds. And therefore, because this is larger than 6.25 that we need, therefore it will not slip, or it will remain in this position.